All right.
Ready?
Yep.
So this is my little fish pump setup here. So we're just circulating some water through a little fish pump. The flow meter is, flow sensor is right here. We've got the bracket. Flow sensor is on the outside of the bracket. We're on a 6mm line right now. I think the intention is that you guys will be using a stainless line or a metal line. So it'll actually be a metal bracket, which David has pictures of as well. But ultimately, we want to show you just kind of the idea of the flow rate and what we're getting from the and how the flow sensor works, what the data is. So as I run my water through the line, you can see that up here on the display, I'm getting about 200 milliliters a minute. As I turn down the flow rate, I've got my little throttle here to start pinching the line down. You can see I'm gonna start dropping down. Now I'm at about 170. This thing can get down to very low flow rates where we can get down to about 6 milliliters a minute. And I'll show you that here as we, on the turn down. Right now, again, we're running at about 58 milliliters a minute. So you can see the flow rate starting to die off a little bit. Now my stream is actually starting to shut down. And down past 20, you'll start seeing it dripping. And just for a little gamesmanship, we'll show you how low we can get with this thing. And you can see here on the display, we're still getting about 9 milliliters, 10 milliliters a minute through just a drip. But just to dork out a little bit, we can get all the way down to right about there. And that's about 6 milliliters a minute.
Wow.
Accuracy on these are plus or minus 0.1%.
Of the full range of the sensor, right?
Yeah, and the repeatable accuracy, I think you're going to actually find you're well within that. So once you calibrate the unit and you can actually to a known flow rate, or if you do a quick bucket test or something and calibrate the flow sensor, the repeatable accuracy of these things is spot on.
Yeah. So a bucket test is like this right here, where we would fill this to some known value and measure that over time, and then compare that with the flow rate there. So right there's 15 milliliters. Yeah. So that'll do it. And then yeah, so this is the sensor right here, and then this is like a little communication unit, right?
So this is actually we call it the relay amplifier, and what this does is it swallows up the heat, basically. So the flow sensor virtually is providing no heat.
Okay.
In some processes, it's really heat sensitive, so we don't want to add any heat to the line.
Got it.
Especially
okay.
some of the smaller lines. But
and then that goes to the brain here.
Yep, to the controller. And that controller is going to provide a couple of different ways that you can pull that output. So I believe that the intention is to use a pulse output from the flow sensor. So we can certainly set that up. You can draw the output via 4 to 20 milliamp.
And we can configure the pulses for whatever pulse rate we want, representing a certain flow. Okay. Yep. That'll allow us to make this not drag and drop. Just put a drop-in replacement of the existing flow meter.
Yep. And so the brackets that you guys will be using is actually a metal bracket. So we'll switch the flow sensor that's on the outside of the line here will be the same, but we're going to replace the bracket with a metal bracket that's specific for metal line.
And the nice thing is, flow meters traditionally need like a straight spot before and after the sensor for laminar flow, but because the sensing is so small, Lane said that the length of this bracket provides enough straights inside the tube, so we don't need any straight length outside of what's in the bracket already.
Correct. So all you need to account for is the size of that bracket.
Cool. All right, well, that's the Kian flow meter. Thank you, Lane.